Good morning, everyone. Or it could be afternoon. I'm not sure. It's morning for me. Um, so, welcome to this algebra lesson. This comes from a few different sections of Chapter 5 in the CPM book. And as you can see from the title and from the targets, we're going to look at comparing functions, linear, exponential, and quadratic. We're going to talk about arithmetic and geometric sequences, and then we're going to do a little bit of a review on describing associations, and we're doing that to help us prepare for Chapter 6. You can see also I've included all 8 math practice standards. I would love it if you would just pause the video here, take a little time to read all 8. We will be using all 8 of these in today's lesson. All right, here we go. All right, because this is remote learning, I'm actually going to ask you to be doing some work during this video so you can see the materials that you will need. You'll need your CPM ebook. There's a Google Doc for today's lesson that's loaded up into Google Classroom, and you're going to be handing that in at the end of the video, and that will be graded, so take it seriously. You'll need the Desmos graphing calculator, open that online, a regular calculator, and then if you decide to do some work out by hand before you type it in the Google Doc, you'll want some paper, pen, and pencil. All right, there you have it. All right, so we're going to start. Part 1 is a review of linear, exponential, and quadratic functions. So here's what I want you to do. First of all, do you see this pencil up here in the upper right corner? When you see that on the video, that means I'm going to ask you to be doing some writing. So basically what you need to do is enter those 3 equations into the calculator, and then I want you to, after that, explain in writing which function is linear, which is exponential, which is quadratic, and then I'd like you to tell me how you know that. All right, and you can use, of course, the graph to describe that. In fact, I want you to do that. So describe the graphs and how that helps you with this. All right, so pause the video. I want you to get these done. When you're finished, get the video going again. All right, so when you graph those, you should have ended up with a situation like this here on the right. And I have outlined on the left which is which. So the red line, y equals 2x plus 5 is linear. Y equals 4x squared plus 3x minus 2 is considered a quadratic function, and then y equals 2 to the x power is the exponential function. So just double check, make sure you got them correct, make sure your graphs look like this one. And I want to review a few things, all right? So we'll be referring maybe back to the graphs just a little bit. I'm not going to do a lot with quadratics today, but I will talk about quadratics as we go along. All right. I want to review real quickly linear functions, right? So one of the ones you just did was linear, and of course that means that it graphs to make a straight line. One of the forms that we have talked about for linear functions is the slope-intercept form. Again, this should all be review. Remember, m is the slope, b is the y-intercept. There's a couple of ways that we have used to describe slope. One thing I like is it's what happens to the line every time you go to the right one. So in this case here, y equals negative 2x plus 2, every time you go to the right one, the line goes down 2. And of course, that's going to be a negative slope. We'll talk about slopes in just a bit. If you look at this one here, the slope is 1/4. So that means every time you go to the right one, you go up 1/4. Down here because it's negative, up here because it's positive. The other way to think about slope is rise over run. I especially find that useful when we're talking about fraction slopes. So the run here is 4. So that means every time you go to the right 4, you go up 1. Now, if you think about that, that's the same thing as saying every time you go to the right one, you go up 1/4. Every time you go to the right 4, you go up 1. Every time you go to the right 1, you go up 1/4. Here's these 2 equations right here. All right. This one here, y equals 1, appears not to have a slope. That's because it doesn't have a slope. It's called a zero slope. The way I say these, both x equals negative 6 and y equals 1, is in this case, x always equals negative 6 no matter what the y is. And in this one, y always equals 1 no matter what x is. I wouldn't bother to like try to memorize, is it horizontal or vertical? If you just say that and graph a few points, then you're like, oh yeah, that's vertical. Oh yeah, that's horizontal. All right, let's talk about slopes real quick. All right, you can see we already talked about this positive slope, negative slope. If we have x equaling a constant number, we call that an undefined slope, because if you did do delta y over delta x, which I know you all know how to do, or change in y over change in x, the change in x's would be 0. And anytime we try to divide a number by 0, it's undefined. Think about that for a second, right? I have 0 friends. That's sad, isn't it? I have 0 friends, and I want to split 6 cookies between them. What? All right, you can't do that. That's impossible. Try putting in your calculator 6 divided by 0, or negative 6 divided by 0, or whatever you want to put in divided by 0. It just does not work. But here we do call this a 0 slope, because it will actually be that your change in y's would be 0. So it would be like 0 over 3 or 0 over 8. And 0 divided by a number is always 0. Right? So for example, I have 15 friends and 0 cookies. Oh, I can divide that. They all get 0. All right. Hopefully that makes sense. All right, moving along. I want to review with you real quickly the standard form for the equation of a line. All right. Remember, when we have this, if we're trying to figure out how to graph it, we find the x-intercepts and the y-intercept. All right, so if I wanted to find the x-intercept here, that happens when y is 0. So I would set y equal to 0, solve for x, right? And x would be 4. So you can see my x-intercept is 4, 0. I would also find the y-intercept. So the y-intercept happens when x equals 0, all right? So if x equals 0, y is going to equal 3. So you can see right here, it's 0, 3. All right, so here's a few examples here. If you need a quick review of that, I'm not asking you to write it down, but just stop and think about that and see if you can figure out why the x and y intercepts are what they are. All right, next. All right, now I want to move into exponential functions real quick. Again, this should be a review. All right, I'm going to move my face down here so you can see, oh, there's a pencil. That means I'm going to want you to stop the video and write some things here. All right, this comes from section 5.1.1. In case 3, see if you remember this. This is the rabbit problem. Lenny and George begin with 2 rabbits, and each pair of rabbits has 4 babies per month. Right here is the table that goes along with that, and here's what I want you doing. I don't want you to read this problem. I want you to figure out why it triples with every month. All right, pause the video, work on that. When you're ready, come on back. All right, here we are. All right, I'm going to actually move my face, I think right up here over where it says warm up. It's not really a warm up. Question 3. All right, I'm hoping you figured it out. All right, I used a bar model to try to help me figure it out. I'm like, okay, month 0, they start with 2 rabbits. Month 1, it says each pair basically has 4 babies. So this is a pair. This pair has these 4 babies. So if you look down here, I think about it as each pair of rabbits has 2 pairs. But of course, the original rabbits are still there. So you really end up with the original plus another pair. So you really end up with 3 pairs per month. So it triples. And then the same would hold true of the rabbits, right? You got 2 rabbits. Each pair has 4, so that's 2 more pairs. That's really then going to be 6 rabbits. That's still a situation where it triples. All right, I graphed it right here. I decided to make this a discrete rather than continuous graph. So there's a review of that term. I hope you've all got that, right? Because it's not like you can have, half a rabbit, or they're going to have like a litter halfway through the month, right? So this one, because it's separate, distinct events, a discrete graph is the way to go. All right, moving along. All right, so back to exponential functions. Nope, I got a pencil here. All right, so I want you to think about this. There's something called half-life, and you can see right there the definition for that, how long it takes a value to cut in half. And I got this from Math is Fun. The half-life of caffeine in your body is about 6 hours. All right, I'd like you to read problem 4, A and B. I want you to do both of these. I want you to use this table as a guide. All right, so pause the video. When you're ready, come on back. All right, here we go. All right, so your table should look something like this over here if you did it correctly, and I hope you did. All right, and then when you graphed it, it should look like this. And I'm not going to go over what the differences are between the two. I expect that you've got something good written there, and I'll be reading it later. But I do want to say the situation with the rabbits is something we call exponential growth. Right, so I've got a sample right here. Let me move my face just a little bit so you can see the exponential growth. And this is also a situation of exponential growth. I used a different graph and I made it continuous so you can see. Right, so the rabbit situation was exponential growth, and then this situation is exponential decay. I think probably that's kind of self-explanatory why this one's growth and this one is decay. All right, so wanted to make sure you had those terms down. All right, moving along. All right, one thing that you're going to be working on in your next homework assignment is arithmetic sequences versus geometric sequences. Right, so an arithmetic sequence happens if you're adding the same value each time, and a geometric sequence happens when you're multiplying each value. Take a look at these patterns. I think you can see that, right? And guess what? All right, this probably goes without say, but I want to make sure that you see this connection since we're really working on linear and exponential functions. Arithmetic sequences are linear, geometric sequences are exponential. All right, moving along. All right, hard to see because my face is in the way again, but pencil. All right, here's what I want you to do. This has to do with sequences. I'd like you just to read the instructions, right? Do A and B. And when you're ready, come on back and we'll compare answers. Okay, so here are the answers that I found, right? And I just want you to compare, right? So this one here might have tripped some people up. It is a geometric sequence, even though you're like, well, I was dividing each time, not multiplying. Think about that for a second. Multiplication and division are related. In this case, dividing by 2 would be the same as multiplying by 1/2. So this one also is considered a geometric sequence. All right. Hey, this thing at the top, you want something fun to do? This is optional. But I would love to have you, if you do this, let me know. Just jot me a little note like, yeah, I looked it up and here's what I learned. There's something called the Fibonacci sequence and the golden ratio. They are related. So take a look at those and then look up ways the Fibonacci sequence shows up in nature. It's a pretty cool sequence. All right, moving along. All right, the last thing that I want you to do today is take a look at this. This comes from section 4.2.1 in the CPM book. So if you'd like, it might be easier for you to go back to your ebook and look at that. It's kind of hard to read it on this screen, but I want you to pay attention to various ways we describe associations. And you're going to use that on the next page. All right. As you can see, I have just 2 graphs here. I want you to describe each of these associations, and you should have 3 words with each association. All right. So pause the video, do that. When you're ready, come back. All right. Here we go. Here's what I had. I described the first one as a strong, positive, nonlinear. And then I described that second one as a moderate, negative, linear. If you had something different than that, just clarify to me why you disagree with it, because it's somewhat subjective. All right. Hey, you guys, that's it for this video. All right. Let's just take a little time. I want you to reread these learning targets, and I want you to just jot me a quick sentence. Yeah, I think we did it, or no, I don't think we did, and here's why. All right. And last but not least, I want you to hand your work in. All right. I know that I said there was a Google form. That might not be true for all classes, but if your teacher gave you a Google form, get that handed in.